All right, remember, Monday is going to be your Chapter 6 quiz. I will be relying on your homework submissions, which this is a very short chapter, so if you haven't submitted, I will be walking around today with whatever little time I have to get a gauge of what you currently know, because those are the information I'm going to write into your reports. Okay? So this is the last bit. 6D and E is going to be part of the quiz, but the main one was 6A and B. So ratios, stuff I did yesterday. Today is more of an addition. So the last few questions on the quiz is a bit about rates. That's more of a challenging question. If you have done these exercises, then you should know. But if you haven't done it, then you may not know for the quiz. Okay? And just tells me where you're at when it comes to ratio and rates. Here we go. Let's look at exercise 6D. First thing is we're going to talk about the difference between a ratio and a rate. So let's fill this in. A ratio shows the relationship between the two, so write that in, two type of quantities with the, and this is the main part, with the same units. Okay, so this is a ratio, has the same units, whereas rates shows a relationship of two different types of quantities with different units. That's one of the biggest things that separates them. Why? So let's have a look as an example. See, as an example, if I talked about $2 to 50 cents, right? Notice that the units are not the same units when I write the ratio. So what's the problem is if you write 2 to 50 without the units, if I just block it off and you just saw 2 to 50 like that, you naturally, in that ratio, you would think 50 is bigger than 2. So you think it's 2 parts to 50 parts. So you would say 50 is larger. But the reality is that 50 cents is a lot smaller than $2. That's why in ratios, one of the first key things is the units have to be the same. Okay, that's why. Otherwise, the proportioning when we're comparing them doesn't make sense. So units need to be the same. Therefore, if you were to write it properly, it should have been 200 cents to 50 cents or 2 to 0.5. That's the way that then you can compare and say, how much more is it? And then you can figure out the ratio there. Yeah? So ratios have to have the same units, whereas rates feel similar. It doesn't. See, rates, on the other hand, something like $1.45 per liter. See, they're different units. One is measured in terms of liters and one is measured in dollars. But the rate tells you things. When you go buy petrol, as an example, $1.45 per liter, your car could take maybe 50 to 60 liters. You can work out roughly how much it is to fill up a full tank from empty because of that rate. Yeah. So rates and ratio feel very similar, but the difference mainly is the units. Units need to be the same for ratios. So for example here, boys to girls. Yes, boys and girls are different, but the way you count them, number of boys versus number of girls. So the number is the unit. Yeah. Cents to dollar. These two are not in the same units. So to make them as a ratio, both of them has to be dollar and dollar or cents and cents. Okay? Kilograms to grams, same thing. They're different units. So if you wanted to write a ratio between them, it has to be grams and grams or kilograms and kilograms. Okay? And then liters and milliliters. Same thing. Yeah? All right. Let's see if you understand what I just described. So first thing is to understand the difference between rates and ratios. Here we go. I'm going to give you 30 seconds. I want you to circle on your page which ones are rates. A, B, C, D, E, F, G, or H. There's more than one. 30 seconds starting now. Five, four, three, 2, 1. Bo, give me one that you think is a rate.
B.
Very good. 180 mils per minute. So minute is the time. That's a different unit to mils, and you're comparing two quantities. Has to be two quantities, right? I just realized I did that. That's terrible. Anyways, 180 mils per minute. Yes, that is a rate. B is a rate. What else is a rate? Let's go, Leon. C is a rate. Yes, this is $60 per hour. So one is in dollars and one is in time. Both different units. And again, you're comparing two different quantities. Yes, C is a rate. Which one is also a rate? Let's go over here, Ashwin. Beautiful. E is also a rate. Okay, 4.2 runs. So for every over, it is 4.2 runs. Two different units, two different quantities. Give me another one. Let's go with Ava. H is also a rate. Very good. 84 cents per liter. One is in money in terms of dollars or cents, and one is in liters. Two different units. And there is one more. Lucas? F. 0.6 grams, so grams per liter. Can I get a show of hands who got all 1, 2, 3, 4, 5 options correct? Beautiful. Good. So that's the first thing about rates. So first exercise, 6D for rates. You need to know what is a rate, and then once you know what a rate is, our aim is to simplify it. So here's the first one. Example 1, 21 students for 3 teachers, or technically 3 teachers. So 21 students for every 3 teachers. Now this rate is fine. There's nothing wrong with the rate. It's just every 3 you have 21 students. The problem is that most times the way we read things, when you go buy things out at Woolies, they have a tag. If you don't realize, it actually tells you, how you can compare which one's cheaper to buy. They'll measure it per 100 grams. So sometimes you buy a packet of chips, they'll say $2 something for 500 grams here. Then it's like $3 something for 450 grams there. It's hard to compare which one is cheaper. So on the tag itself, as they give you the price, just below it, they usually do out of per kilo or they do per 100 grams because then it's measurable, because then everything is all measured at 100 grams. How much does it cost per 100 grams? You can then know which one's cheaper. So the rates, we generally prefer when it's per something. So instead of per 3 teachers, we generally prefer how much is it per teacher? How many students per teacher is the rate? And that's called simplifying rates, making it smaller. So in this case here, instead of 3 teachers, how do we mathematically go from 3 to 1? What do we have to do, Leon? Yeah. 3 teachers divided by 3. 3 divided by 3 gives me 1 teacher. But whatever you do to one side of the rates, you have to do to the left as well. So whatever you do, you keep them the same because it's the same rate. So divided by 3, 21 divided by 3 gives you 7. So that means the rate is 7 students per teacher is one that people generally understand better. So if I said, we need at least 7 students per teacher, that is the rate that we need on a camp or on a group, then it's easy to work with 7 per 1 rather than 21 per 3. Okay? So that means if you do the next problem, same idea, you got $30 for every 5 kilograms. But again, like you go into the Coles or Woolies, they usually charge per kilogram because it's easier to calculate. What if you don't want 5? What if you wanted just 2 kilograms? It's easier to work out 1, then you can work out 2. Yeah, so let's do the same thing. How do I go from 5 mathematically down to 1 kilogram? Divided by 5. Whatever you do to one side of the rate, you must keep the rate the same, right? So divide one side by 5, divide the other side by 5. $30 divided by 5 gives you what? Let's go with Tom. What's 30 divided by 5? 6. So this tells me, instead of saying $30 per 5 kilos, $6 per kilo is more common. And that's how you know. That's how you compare between different shops. Is this cheaper or is that more expensive? You can tell because it's based on per kilo. That's why sometimes they actually change this one. If you go look at Coles and Woolies, sometimes they just change it to, say, $5. Instead of per kilo, they say each. Because you don't know how much it actually weighs on average. It's harder to actually work out which one's cheaper. So should you buy it as individuals or should you buy them as an actual bag per kilogram or per weight? And that's part of understanding mathematics, that you can actually do those calculations yourselves to figure out which one's better. Yeah? But usually the supermarkets usually have the rates. That's one of the things I think A lot of buyers don't know. My wife didn't know until I told her. I said, this is cheaper. She's like, how did you know? I'm like, look, each one has a rate. And if you look at it now, you can see each one has a rate. And the ones that don't put the rates, that's when I question. I'm like, well, I wonder why they're not putting the rates. It's probably because it's a bit more expensive and you can then work it out. So sometimes I need to change it to liters and then work out how much is it per liter, which one's actually cheaper. That's what I'm using. I'm using the skills of rates. All right, let's try this one. So this is a problem-solving one that you can figure out. Let's have a look. Michelle grew from 90 centimeters to 130 centimeters over 5 years. Okay, and the question is, what is the average rate of growth per year? So I just want to know per year. Instead of over 5 years, I know she's grown, but I just want to know, on average, how much has she grown every year? Now, when I first asked that question, it might feel, well, that's so much thinking. But we can break that apart and think about it logically. Let's go. From 90 to 130, how much has she grown in 5 years? 40, very good. So we know it's 40 because we say 130 minus 90. We started off at 90, you ended up 130. So subtract them, it's 40 centimeters. Now, this makes much easier to understand. Now, that means in 5 years, she grew 40 centimeters. Very good. So here, this is your rate. 40 centimeters per 5 years. But we don't want per 5 years. It's much easier to understand when it's per year. So in per year, like Matteo just said, divided by 5 on the right to make 5 to become 1. Therefore, on the left, dividing this by 5, 40 divided by 5 gives you 8. So now we can say, on average, it's 8 centimeters per year. Now, the key word there is average, because it doesn't mean every year it's 8, 8, 8, 8. Average means that it could be in 1 year, it could have been 10. Another year could have been 6. And then the other year could be actually 8, and then 7, and then 8, for example. The point is, the average works out to be 8, on average. That's what the average means. Over time, what is the one number that summarizes that change? Okay, that's what average actually does. All right, flip over the page. So what you've learnt now is you've learnt how to understand when you have a rate. You've learnt how to simplify a rate. In exercise 6E, which is the main one, and that's what's going to be on the quiz, is how do you apply the rates? How do you use it to problem solve? So we'll start off with a simple one. Here's a simple example one. Joanne or Joan can type 80 words per minute. How many words can she type in 25 minutes? So we've got a rate. We know that every minute they can type 80 words. The question is, in 25 minutes, how many words can they type? Remember, you can use a calculator for the quiz. So you don't have to do this by hand. Do it with a calculator. How would you? Beautiful. So we know times in this by 25 because it's every minute. You got 25 minutes. So times it by 25 on your calculator. 80 times 25.
2,000.
Yes, that is correct. So that's a simple rates problem. Okay, so we've got a rate, and then we move forward, and we can say it's 2,000 words per 25 minutes. Let's go just a bit. This is still an easy one, but I'm gonna get you to think about the logic. What if I change the numbers? Okay, so look at example 2. Oh, sorry. Let's have a look at example 2. 25. You've got now 60 hot dogs that were sold every 20 minutes on average. So this vendor is selling on average every 20 minutes is about 60 hot dogs, right? What he's curious, or the vendor is curious, is how much would they likely sell if they had 210 hot dogs in stock? How long will it take? Okay, so at this rate, the question is, how long will it take for 210 hot dogs? Now, most students...
So how long will it take to sell one hot dog?
Yeah, so there's a lot of ways to do this. This is very good. So you could work out how long does it take to do... how long does it take to do one hot dog? And once you know how long it takes for one, you can then work out for 210. You could also do another way as well. You can actually work out the ratio. 60 times what gives you 210, and 20 times that factor. Now, if I change that number instead of 210, I'll give you a number, then you definitely know the answer. What if I change it to 120? Okay, so everyone can jump in and quickly say it was times 2. But my question is, how did you get 2? Because if you can figure out how you got it, then you can do it for 210 as well. Okay, one way is doubling it. But what's another way? Because if I gave you 210, it's not easy to just work out what you multiply. Let's go back. I want you to give me a method. I don't want you to use intuition. I want you to give me a method. If you got 60 and 120, how do I get 2 rather than guess and check? Because I know we intuitively know it's double, but instead of doubling, there is a technique. You can use 120 and 60 to actually work out it's 2. Yeah. You take the 120 and you figure out how many of those 60s fit into 120. And conveniently, it does work out to be 2. But even if it doesn't conveniently work out, for example, the question I gave you, 210, you don't need that to be a nice whole number. That's just the fraction. That's the proportion. So on your calculator, you literally can just type 60 times 210 over 60. That's fine. Obviously, if you know a bit more fraction skills, you can simplify that. You don't have to times it by, so like I said before, 120 over 60 happens to be the same as 2 over 1. And then you said, oh, just times it by 2. But what if it isn't 120? What if it was 121? You still do the same thing. You still say, how many 60s fit into 210? If you can simplify it, great. If you can't, this is the factor. That's what you're going to multiply it by. So here on your calculator, you're really just doing 60 times. If you want to know, to get 210, it was 210 out of 60. That's the factor to get here. That means whatever you do to the left, you do to the right. Times by 210 over 60. So right here, again, you can use a calculator. What does it actually mean when you say, how do you calculate 20 times 210 over 60? On your calculator, you really type 20 times 210 divided by 60, literally. So here we go. I'm going to type it on my calculator. 20 times 210 divided by 60. 70 minutes is how long it will take. So here we go.
Wow.
Now, if that technique, that's the most direct, most efficient way to go from this one to this one and this one to this one. But let's say you wanted to do it a different way, you could have. The way that Bo described it, that would have been a better way too. Okay, so if you didn't have a calculator, what's another way to do it? Bo's method would have worked. Bo's method was to find it, what is it per minute?
It just says.
Oh, so not per minute, per hot dog.
How long will it take to sell one hot dog? That's what it says.
Oh, did I say that?
No, that's what it says in the sheet.
Yeah, because I wrote it there. Sorry. So that means I guided you. But yes, that is another way to do it as well. So if you worked out how long does it take to just sell one hot dog, well, now you can think about it. From 60, how do I go to one hot dog? Divided by 60. So you could have done it from here. You'd say divide this by 60, and then you go from this side, 20 divided by 60. Now what's 20 divided by 60? 1/3. This is 1/3, but even if you didn't know it was 1/3, you could have left it as 20 over 60. Nothing wrong. So you can say it takes 1/3 of a minute, or you could have wrote 20 over 60 minutes. That's okay. Nothing wrong. Now what's your goal? Your goal is you've got the price of how long it takes for one hot dog. How do you go from 1 to 210? So you now know it's for every one hot dog, it was per 20 out of 60 minutes. That's your rate. I'm asking if you want 210 hot dogs, how long? See, how do you go from 1 to 210? Yeah. You times it by 210. from 1 to get to 210, you times by 210. But whatever you do to one side, times it to the other. And it ends up being the same technique. 20 over 60 times 210 is not different to what I showed you before. See, that's the same thing as saying 20 times 210 divided by 60. On your calculator, same thing. So you could have done it many ways. You could have worked out what is the rate for just one hot dog and then times it to 210 that you want. Or if you use my sort of method, I'm using your intuition. So if it was 120, you knew it was 2. So what happens if I change it to 210? How would you work it out? It's the same idea. You would take this amount divided by that, and that's your factor. That's how much you need to multiply. So 210 by 60, and then do the same on that side, and you're done. That to me is the most efficient, the most effective way to do it. But why do students not use this technique? It's because it's not intuitive. And for them, that's harder to do when I put a number that is not multiples of 60. Reality-wise is that most things don't fit nicely in life. Everything is slightly off, so you have to be comfortable with working with numbers that don't fit. That's why you have a calculator. That's how you use it. Yeah? So, the answer for this question here was 70 minutes, and the best way, in my opinion, to do it was when you knew it was 60 hot dogs per 20 minutes. My opinion, the quickest way to solve this problem was you literally work out 60 times what to get 210. Well, you just work out how many 60s fit into 210. That's what you're timesing. Times it to both sides.
3.2, 3.5.
Good. So you can change it to decimal. So we can do 21 divided by 6, 3.5, times it to 20, and you still get your answer. Okay, so if it helps, if you don't like the fractions, change it to decimals, but you need a method to be able to figure out 70 minutes. Okay? Now, the last problem, I gave the other class 5 minutes, and some of them were able to figure it out. Some of them took some time and they still didn't figure it out until I explained it. I'm going to give you the same thing. I'm going to give you 5 minutes. It's 10:43. 5 minutes. I want you to flip over the page, and I want you to see if you can work out this problem as well. Okay, so here we go. I'm going to flip over the page. Here's the problem. Imagine you had 2 hoses. You want to fill up the pool. You got the one at the front of the house and you got one at the back of the house. The first hose, it takes 100 hours to fill up the pool. The second hose from the back, you poured it over and it's slower and it takes 150 hours to fill the pool. So you're like, you know what? Instead of filling one at a time, how about I put both hoses into the pool? How long would it take for both hoses to fill up the one pool? Now that's a rate problem, and I already give you some hints. So if you follow my guide, you should be able to figure it out intuitively. So 5 minutes, you should be able to figure it out. So one hose takes 100 hours. The other hose takes 150. But what if I put them both together?
It takes 50.
All right, work it out for me. I've got 5 minutes. It's 10:45 now, so by 10:50, I want a solution, and I want to see your thinking. How would you solve this problem? I'm going to pause. I'm going to continue recording. So let's have a look. Hopefully you at least tried to follow my guide. So I wrote the notes so that it guides you to think how to get there. So first part. Hose 1, we already told you that it takes 100 hours to fill up a pool. So here we go. Takes 100 hours for the first one. Second one, we said that it was 150 hours to fill the pool. See, the problem right now is that when you put them both together, you can't add them because they're running at a different rate. Okay, it's like saying if I was running at 10 kilometers per hour and then someone else is running 5 kilometers per hour, you can't just match them together. It's not the same rate. Okay, so because of that, for your FYI, this is why you can't do half plus a third. You see, half, if we're thinking in terms of pizzas, that's half of a pizza, whereas a third of a pizza looks different. Doesn't make sense to count them together. They're different units. Or like chairs. If I have this chair, this comfy chair is different to the chairs you are sitting on. I can't count them as 2 of the same comfy chairs. So the same thing here, I can't count them as 2 halves or 2/3. They're totally different. So that's why when it comes to rates, with the hoses, you can't add them together because they're running at different rates. So one of the first steps that you have to do is you have to find Where are they in common then? So this is what I did. I gave a table for you to help you see the pattern. See, hose number one pull per 100 hours. 2 pulls will be 200 hours. 3 pulls, 300. 4 pulls, 400. 5 pulls is 500. It carries on. Then I look at the same thing for the second hose. Second hose is 1 pull is 150 hours. 2 pulls is 300 hours. 3 pulls is 450. 4 pulls is 600. And then 5 is 750 and onwards. But what we can see here is that there was a time where they both have something in common. 300. In 300 hours, the first hose could fill up 3 pulls. The other one, so remember when you pull it in, when you put it together, this is the rate. This one is for every 3 pulls, for the first hose says, oh sorry, where's my pen? First hose is for every 3 pulls, they can do it every 300 hours. This one tells me they can do it every 2 pulls. So every 2 pulls, they can do it in 300 hours. So in 300 hours, both of them have the same rate now. They both run at per 300 hours. And because of that, every 300 hours, with 2 hoses together, how many pulls can they actually fill up? Not 4, 5. Because one hose can fill up 2, the other hose can fill up 3.
Plus 50 hours.
So 2 plus 3 gives you 5 pulls per 300 hours. This is why I wrote here, I said, so that means together, the pull for, so the hose 1 and hose 2, every 300 hours, they will fill up 5 pulls. But that, as a rate, is not useful to us. That's why we then try to work out per pull. So if it's 300 hours per 5 pulls, let's work out for 1 pull. How do you go from 5 to 1 pull? Divide by 5. So whatever you do to one side, do it to the other. What's 300 divided by 5? 60.
Yes.
That's how you work this out. Now, this is me guiding you through the logic to why it works. Mathematically, Bo. I'm going to ask you to walk outside for a moment, please. Just step outside. Thank you. Just to wrap up, this bit here, if there is another way, you didn't actually have to do multiples, find lowest common multiple to get to the answer. The other way that you could have done it was that we knew it was 1 pull, listening, per 100 hours for one of the hoses, which technically you can write it as 1 out of 100 because that's what it means. It's 1 per 100. This is for hose number 1. Hose number 2 was for 1 pull, it was 150 hours. So you can write it as a fraction and it's 1 out of 150. And you'll see here, if you want to combine them together, remember, they're running at different rates. Just like fractions, you can't add them because they're different. Sorry, I did want you to just stay out. I was going to speak with you. So you can't add these two together because they're running at different rates. But with fractions, we have learnt you can actually add fractions together if they have the same denominator. So here, you're really actually just doing this. That's the mathematics behind it. You're actually just doing what's 1 over 100 plus 1 over 150. That skill that you learnt in fractions is what we use to solve this kind of problem. So if you worked it out, can you see this was just timesing it by 2 to make it 300. That's the lowest common multiple. Times this by 3 to get your lowest common multiple. And you can see your fraction ends up being now 3 over 300 plus 2 over 300, which gives you an answer of 5 over 300. And that means it's 5 pulls per 300 hours. And then from there, you can actually work out per pull. Okay, so this is the mathematics. But had I just done that for you, you would not understand why that works. I wanted you to see the logic behind it, Why do we need the rates to be the same for you to add? So when students say, when will I ever use fractions? You don't actually need to know how to add manually, but you have a calculator. You have to be able to use a calculator to solve your own problems. And that was a typical problem if you had one rate for one thing and one rate for another, and you just wanted to know how long will it take. It's nice to know if it's going to take 60 hours putting that in, you can come back 2.5 days later, know that it will be close to full, rather than just sit there and wait. Say, oh, I came back 3 hours later, it still takes a while. There's a reason why we use rates and fractions, yeah? So hopefully that was a nice problem-solving one. That one is at extension level for you to think about. That's for you to problem solve, but the skills that I need you to do are the ones that we just did before, okay? Especially example 2. So if you can practice with example 2, those are the kind of questions I'll be putting on the quiz as an extension, but you need 6B, 6A ratios, okay? You now have half an hour. This is your time. Practice 6B ratios. Have a look at 6E, 6D for rates. Prepare for Monday's quiz.